Hi, I'm Dr. Papya Bhattacharjee. In this problem, we have two limits given, the limit of a function f and limit of a function g. What we have to do, we have to evaluate these three limits of these three new functions. One is fx plus gx, one is fx times gx, and the other one is fx over gx. So the addition of the two functions, the product of the two functions, and the quotient of the two functions. So we will be using the properties of limits to evaluate these new limits. Let me remind you of some basic properties of limits. So if we have, so limit of a function is L, some value as x approaches to c, and we also have limit of another function as x approaches c of a function g, says m. So in general, if we have limit of a function f is L and limit of a function g is m, when x is approaching to c, the basic properties of limits can be applied, and we can figure out the limit as x approaches c of the sum of the two functions f and g. And the property says that if both of these limits they exist, then we can separate limit of a sum as sum of two separate limits. So this is equal to limit as x approaches c f of x plus limit as x approaches c g of x. And notice this limit of f is given to be L and limit of g is m. So when we have sum of two functions, both limits exist separately, we can split the limit as sum of two limits. Same thing can be done with product and quotient as well. So when you have limit as x approaches c, you want to figure out fx times gx. Again, both of those limits exist already. Then you can split it into product of two separate limits. So you will have limit of f times limit of g. And if you plug in their values, this is just L times m. Last one is the quotient. So you want to figure out limit as x approaches c of fx over gx. And we can do the same thing. We can just split it into two limits, limit of f over limit of g. There's just one thing you have to be very careful about that. So let's write that down, limit of f as x approaches c on the top, limit of g as x approaches c on the bottom. And then same thing again, you just plug in the values. So you can have L over m, but notice there can be one situation where the limit of g, this value m, is 0. And if that's the case, then you're dividing by 0, which is undefined. So we have to be careful about this. So this is only true when m is not 0. That's one restriction we have. Okay, so these are the basic properties, some of them. Let's go back to our problem. We have limit of f is 3, limit of g is 9, and we have to apply these operations and figure out these three limits. So the first one, limit of fx plus gx, note this is just L plus m. And what is our L? L is 3. What is our m? It is 9. So this limit is just adding the two numbers 3 plus 9, and that is 12. For part B, we want to figure out the limit of the product of the two functions. So go back here, the product, the answer is L times M. So you just multiply the two numbers, 3 times 9. And that is 27. And the last one, we have to do quotient. Again, go back to our basic property here. And remember, we can divide the two numbers, but you have to be careful that the denominator is not 0. And notice here the denominator is going to be 9, which is not 0. So you plug in 3 over g is 9. And so this is 1/3. So those are the 3 limits for 3 new functions. Thank you.